Hey Algebra I, it's Mrs. Freeman. This is lesson 5.7 and today we're doing systems of linear inequalities. So remember, systems is just more than one. So this is going to kind of tie what we learned in 5.6 together with what we learned for the rest of the chapter. So first I want you to graph these inequalities. Go ahead and pause this video while you do that. Okay, for these inequalities, I've got y is greater than or equal to -1. I'm going to graph that just like this. And I'm going to do it with a solid line because that's greater than or equal to. That would be a horizontal line at -1. But for the graph of an inequality, I have to shade, and I want the y's that are greater than or equal to -1, and those are going to be up here. Number 2, I've got to move some things around. I want it to look like y equals mx plus b. So I want this guy to come over here. When I do that, he's going to become negative. And now to get y by itself, I have to divide everything by -5. Well, what's my rule for inequalities when I divide by a negative? I have to flip this sign. Don't forget that step or your shading is going to be the wrong direction. Here's what I get whenever I divide. My negatives cancel for my slope, and then I've got -3/5 for a y-intercept. That's not a very pretty y-intercept, but it's going to be a little bit over halfway. And then I'm going to go up 4, 1, 2, 3, 4, over 5. This time is a dotted line. And the y's that are greater than that are above the line. Okay, then, again, I got to move my x over. I'm going to get -4y is greater than or equal to -7x minus 9. Something very similar is going to happen because I'm dividing by a negative. I'm going to get y is less than or equal to, because that has to flip because I'm dividing by a negative. 7 over 4, my negatives will cancel. And again, my negatives will cancel, so plus 9 over 4. 9 over 4 is 2 1/4, so it's a little bit past the 2. And I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7 over 4. This is a solid line because it is less than or equal to. So remember, you have to flip that sign. If I wouldn't have flipped the sign, then my shading would have been above the line here because it's greater than or equal to, and I would have got it wrong. All right, example 1 says, tell whether each ordered pair of the solution is a solution, of the system of linear inequalities. So remember, for this to be a solution to the system, it has to work for both of those equations. So it has to work for this one, and it has to work for this one. So if I plug these in for x and y, I'm going to get 5 is less than 6. That is true. And I'm going to get 5 is greater than or equal to 4. That is also true. So this is a solution to that system of linear inequalities. If I do it over here, I'm going to get 0 is less than or equal to 2 times -2, which is -4. This is already not true, so I don't need to do the rest of it. If it doesn't work for one of them, then it is not a solution to the system. So this is no. Okay, example 2 says we're going to graph the system of linear inequalities. That just means we're going to graph more than one, and we're going to graph them in the same coordinate plane. I'm going to graph these just like this. Y equals 3 would be a horizontal line at 3, and this is less than or equal to, so I am going to do it with a solid line. And my shading is going to be under since it is less than or equal to. Okay, and then I have y is greater than x plus 2. I'm going to begin at 2. My slope is 1, so I'm going to go up 1 over 1. And this time it's just greater than, so my line is a dotted line. But the y's that are greater than this line are going to be above this line. Okay, so my solution now to this system of linear inequalities is this region right here that I'm circling where both shadings are happening. That's why I just drew lines this time. So you can see right here where these lines are intersecting, where both areas are shaded. That is my solution. So again, if they give you an ordered pair like 5, 2, and they say, is this a solution to this inequality? Well, it better fall in that region right there. If it doesn't, then it is not. Okay, let's graph this system. So I need to get y by itself in these because I need them to look like this. So I'm going to move my 2x over in both of them. In my first one, I'm going to get negative 2x minus 1. And in my second one, I'm going to get negative 2x plus 3. So going ahead and graphing these, I've got negative 2x minus 1. I'm going to begin at negative 1 and go down 2 over 1. And this is going to be a dotted line. And then I have negative 2x plus 3, so beginning at negative 3, down 2 over 1. Notice these lines have the same slope. What does that tell me? It tells me they're parallel. This first line that I made, I'm shading the y's that are less than it, so that is here. And this is here. So notice these are never going to intersect. So this would be an example of no solution, because my solution to the system is where they interlap each other. And that's never going to happen here because I'm shading below one and above the other, and they're parallel. Okay, last one. Write a system of linear inequalities represented by the graph. So I'm doing this backwards. I want two equations that go with this graph. Okay, so if I do this dotted line first, I know the dotted line is going to use one of these two signs. Notice that it's shaded below the dotted line, so it's going to be less than. So what I need to figure out is the slope and the y-intercept of the dotted line. The y-intercept is 0, so my b is 0, and it looks like I'm going up 1 over 1 for the slope, so my slope is 1. Okay, so that would just be y is less than x in simplest form. And then my second equation, which is this solid line, it's shaded above the solid line, so that is going to be greater than or equal to. This is just a horizontal line at -2. Okay, so that was just me doing that backwards. I found the two equations of the lines that were given to me in the graph. Did the same thing I was doing earlier, I just literally did it backwards. So my solutions here to this graph would be this area that's shaded light blue here. It's where they overlap. All right, that's it for today. Go ahead and try your big ideas and let me know if I can help you. Have a great day.